We're going to demonstrate the game Connect 4 right here, right now, okay? The well-known classic Connect 4, it's a game for 2 players. So how does it actually work? There's a board, right? Here you're seeing 2 windows with the same board. This board, it's the real game, right? Physical, it stands vertically, and each of the players has a color, a blue and a yellow, for example. And then he chooses one of the columns and he drops a chip. He releases a chip into the column. This column, actually, it's a slot, and the chip goes falling to the bottom. And the goal of the game is the first player who manages to make a line of 4 chips of the same color, right? Of their color, he wins the game. It's like an extended tic-tac-toe, right? Except the difference is that the chip falls to the bottom. You can't place it in any position. So let's start here. I'll play here in the last spot of the first column. My color is red. And then the bot, right? The agent actually played right here in the middle, right? Here in this first window, it's my human client. And here is the machine bot client. This first window, it's connected with the mouse, right? And the second is connected with the execution of a script. So when it's the machine agent's turn, it just runs the script to see the next move. So I'm going to play here now just for a little while because I think it's a good spot. Let's wait. The bot played. Okay, I'll play here. Now let's wait for the bot. I guess I'll play here to mess him up a little bit here. Play, geez, not many options. I have to play here, otherwise he wins. Play here. He has to play here. If he doesn't play here, I win. See? He's gonna mess up my move. Now I'm going to play here. Now I play here. Now I play here. I lost. Why did I lose? Because now he set up the move here. And if I block, he wins here. This algorithm is quite interesting. Actually, every single time I've played against it, I've lost. It's a search algorithm, okay? It's an alpha beta, right? With minimax. Well, it can definitely win here pretty easily. There. So it won here. I want to show a bit of the behind the scenes now, right? I'm going to bring this window over here. This window is my matrix server's window. Just to recap, the matrix server is a central server for Aletheia, right? So each matrix server, it can actually have, well, it has a thread that comes from the main matrix, right? From what we call the root matrix. And in addition to that, you can also create other matrix server nodes within the same process. A matrix server is a logical division, and under a matrix server, you have the Aletheia servers. Which are these? In this case, there's only one, this one here. And under the Aletheia server, you have the environments. What is an environment? An environment is like this. Imagine you have an AI problem and you're going to develop an agent. This agent will act in a context. It will interact with an environment. This environment has its properties. So the environment is it's the environment where the agent acts, right? And it can be one or more agents acting in the same environment. And in this particular case, here we have an agent and a human player who are both playing. And the environment in this context is this. It includes the board, the pieces, all of that definition, the rules, right, of the game, the turn logic, whose turn it is to play. Basically, all of that is part of the environment. And so what can I actually do here? Show you how it works. I'll open Script Studio. This is Script Studio. And here I have the built-in agents. It already comes with Aletheia, the game ones, which is tic-tac-toe, which is noughts and crosses. I've already opened it for you to see, and Connect 4. In this case, what we're actually using here to play is this JavaScript script core, and here's its logic, okay? So let's take a closer look. Alpha beta. This is the alpha beta script core. So we have the alpha beta algorithm. Here for the move, developed in JavaScript, we have here in the Prolog folder, we currently have the version. This is the one that's available here in Prolog as well. Let me open and close and open here. Just because the session must have expired. There, in this case, here's the Prolog. Except for the Prolog implementation, what's actually happening here is that it's making an internal function call right at this point, which then calls the native Aletheia code that's written in Java, right? The reason for this is that it has the ability to make direct calls to the Java code base. So our intention is to eventually bring this specific piece of code over to the script version as well, so it can be used there too. In Python, the process is essentially the same thing, following the same logic and approach. Yeah, for now, it's only the JavaScript one that's available, just at this time. It has the code right here. Let me just take a look here and see if there's anything else. It's here. This one here is the Prolog one. See, it's already here. Here's the Prolog one, made in Prolog, in the same way as as JavaScript, we have the Prolog one, okay, which is the Prolog script core. The Prolog we have here is precisely what calls the Java code. And this Prolog here is the one that has it in the script. Well, you can create scripts here, new algorithms, right? This Script Studio is a code editor and it's being improved more and more. There are plans to develop a Visual Studio Code extension so that you can connect to a Matrix server. Yes, a Matrix server, and edit your code directly from Visual Studio Code as well. This means you will soon be able to work on your code through Matrix or within the familiar Visual Studio Code environment. This is much more interesting because VS Code is a much more complete code editor, right? And more flexible, and it's specific for you to edit the code. Okay. Let's do the demonstration now of the tic-tac-toe game, of tic-tac-toe. In the same way, tic-tac-toe, I have the alpha beta and I have the JavaScript script core here with the tic-tac-toe code, all right? In the same way, I have the Prolog script core and there's the code in Prolog. But this Prolog code isn't really implemented, right? For tic-tac-toe, for Connect 4, it is. But for JavaScript, it is. So let's play here to see. Bring this window to the corner. And let's go here. Create a tic-tac-toe game here on the Aletheia server, which already has some games, game environment. I'm going to create an architect. This one. Then I'll go ahead and open up a human client for you. And a client machine. Well, let's shrink this window a bit. Could you bring it over here, please? And this one right here is the machine. The game is already connected, so everything is ready. I'll play here. Well, tic-tac-toe is a bit tricky because when both players, the rules are simple, right? And when both players know the rules well, there's rarely a winner. It always ends in a draw. And that's what happened here, okay? In the same way, we executed the JavaScript script core script of this game. Well, this is Aletheia. There are other functions available, and one of them is, let's take a look at the documentation here. There is documentation, okay? You can explore it. Look, the main concepts are listed right here, and then, so you want a helpful tip on how to explore, right? First, let's talk about the guided path. This includes how to create an environment from scratch, understanding the different types of agents and how they work, and playing both as a human and against the machine. We'll also cover using the portal and accessing help resources when you need them. Additionally, we'll discuss playing remotely with other connected players, which is possible because you can set up a matrix server for communication and also set up an Aletheia web interface or platform. Now let's take a closer look at each of these steps so you can get the most out of your experience. Or UI, right? Why UI? What do you mean UI? Because I can go in here where I have my project. And open its swing version. Look, it's exactly the same here. Servers, Aletheia, servers, matrix. Let me think for a moment. This here, which is the synthetic head monitor, all the functions on the web are here. You can open this client and play And you can also call this client directly in game mode, and it will open just a small window to play. And you have to connect. Okay, I'll close it later. In another video, we'll explore all this more. Another interesting feature we have is the synthetic head, because and you're seeing that we have the execution of agents. We have an artificial intelligence environment, we have an artificial intelligence framework. And this framework, it's an agent that can act in any environment. It can act in a simulated environment, and we can model a more complex environment. Like, for example, creating an agent, modeling an agent so that it becomes a personal assistant. That's the idea of this project too. And for that, we're building a visual, a face for it, right? It's still in development, right? There are some problems, some bugs, but I can show it. For now, there's no intelligence in this face. How does it work? I'm modeling the components here are to give expression, right? So actually, I can gently close my eyes for a moment, look, and then open my eyes. I can give it skin. Okay, right? Uh, I can make it smile. The smile is still very buggy because at 0, it already has this kind of sad face here. I need to tune that. Actually, 0 should be straight. And when you put 100, it should be smiling instead of making a weak arc. And minus 100, it should do this. This here is right. And 100 should actually be the opposite, forming an upward arc. And 0 should be straight. But there is a little bug there. The eyebrow. For now, it goes from 25. No, actually 100. This one is 100. And this one is minus 100. And let's see 40. 70, just 70. And minus 100. And 100. So I think it's more interesting like this. Then there's roll head tilt. What's that? Let's see. Let's put 100 here. Actually, it's 25. It's just him moving his head here and there. Then the look pitch. It's if he looks up and down. The look yaw. If he looks like this or like that, right? Then the others are for the scene. Him moving his head in the scene. Then the zoom. And the glow. Which is the lighting. Yeah, and here are some presets, right? Neutral, friendly, happy, which isn't happy yet, right? Because the mouth is bugged. Concentrated, angry, surprised, and sleepy. Anyway, let's improve this, and it won't just be a wireframe. Yeah, let's give it a better shape so it looks more interesting. So that's it for now. There are actually more functions available, but since this video is getting a bit long, I'll wrap it up here. I'll prepare another video later to demonstrate these functions like large language models, also known as LLMs, and vector embeddings. And also how to connect, right? How to create your account. It's already in the cloud. You can access it here. Look. All right. Create your account here in Framework. Create account. It's just that I'm logged into mine. Let me log out. Framework, create account. You create your account. Once you create your account, let me log in here. You won't see this admin tab. This admin tab is only there because I'm an admin. The tab, you'll see the modules tab. In the modules tab, you'll see the list of app modules that you have. And at first, there won't be any. You need to go to the store and buy them, right? In this case here, this purchase is just a simulation. It's not connected to any checkout process yet. And you click, and then it installs the application and it comes here. By doing that, you can open the module. This module is actually one of the management interfaces for the matrix. There are several functions here, but well, to access Aletheia over there, you have to click here on console. When you click, it'll open the console here. Then at this point, you can actually access the Aletheia matrix servers right here in this very place and create your environments, test them. So that's about it. We'll see you in the next one. See you later.